Hi, welcome to Chemistry with Mrs. Mays. Today we're talking about measurement, and with every measurement we need to be talking about error and percent error, because we just might not be perfect. So not having the true value is a mistake with our accuracy, but how do we measure accuracy? Like, how bad is it? By determining the amount of error, we can describe how far off our measured value is from the correct value in our measurement. So, in other words, we take the experimental value that we discovered by our experiment and we subtract the theoretical value from it so that we can see how much difference is there. For example, water in Colorado Springs, since we're above sea level, boils around 92 degrees Celsius. But the boiling point of water at sea level is 100 degrees Celsius. So we take what we got in Colorado Springs minus what we should have got at sea level. And we subtract the two, and we see our difference is negative 8 degrees Celsius. That means, because it's negative, that our experimental value is 8 degrees below what we would have expected. So it's important that we do this in the right order. What you got minus what you should have got. Not the other way around. Otherwise, you wouldn't be able to see that it's below the true value. That's what that negative sign is for. So one thing we have to consider is how critical is the error? Like, for instance, if you missed 12 questions on a test, is that really bad? Well, it depends. If your test is out of 100 questions, then you got an 88%, right? But what if your test was out of 15 questions? Oh dear. Then you got a 33%. So the question is, how do we compare the amount of error to the size of the true value? Like, how big was it supposed to be? Here's what we do. We take the absolute value of your error, what you got, minus what you should have got. Let me move this out of the way. So first take the absolute value of that, because it now matters less if it was too big or too small. It just matters how bad did you mess up. And then we're going to divide that by the value of what it should have been. So what you should have got. This is my redneck way of explaining percent error. So the scientific way is going to be like this. You take the absolute value of your error and divide it by the actual value of what it should be. Like so. And then, of course, to turn a decimal into a percent, you can multiply by 100, or you can just move the decimal twice. So let's work some of this through. To find the amount of error in this example, I have to take what I got in my experiment, 1.24 grams, and subtract from that the true value of 1.30 grams. So I subtract those first, and that is 0.06. 0.06. Then I'm going to take the absolute value of that number. So that's still going to be 0.06 grams, and then divide that by the accepted value, the true value, because that's what I should have got. And then we'll be able to say, is a 0.06 error really bad, or are we doing okay? So 0.06 divided by 1.30, that is equal to 0.04615. But remember, this is our decimal, Multiply this by 100 to turn your decimal into a percent, and then put a percent sign behind it. So we have 4.6% error. And that seems not too bad. If you only had 4.6% error on your test, you would be making an A. That's how we handle error and percent error. So we'll practice this together in class. See you then.